Hello everyone, my name is Anna Kramarz. I come from Micropower Group. Big thanks to Alfredo for organizing this event and for giving us an opportunity to discuss this very important topic, which is battery safety. And I believe that this is a topic that we not really dig too deep into in our discussions with customers. So I'm very happy to be able to discuss it more with you and to introduce you to the world of the battery manufacturer and also give you a bit insight of what we are working with and how we create safe battery systems. Like I said, I'm from Micropower Group. We are a Swedish company founded 40 years ago. We have our headquarters in Växjö in Sweden. We have our R&D centers both in Stockholm and Gothenburg. But we also have global service and sales support around the world in other countries and cities within Europe, also Asia and US. And we are suppliers of complete system, everything from the software solutions, fleet management system, lithium-ion batteries, both components, BMSs, full packs, battery chargers, and power converters. And as I'll speak today regarding our lithium-ion batteries, we have actually around 2 million of our modules produced and operating in the field without any incidents. And here you can see on the picture, this is our headquarters in Växjö, where we have the production of the chargers and the batteries. It's a huge facility, 25,000 square meters, with potential to expand to 3 times the size. So we just hope that you're gonna keep the battery projects coming in so we can expand our operations. And of course, if you ever come to Sweden, you're very welcome to come and visit us to see the Scandinavian design. So, a little bit about today. We're gonna look on the battery safety from the AGV perspective. I will talk a bit about how battery fires happen, why they happen, and also most important, how we address them with good system design and control strategy. And a note on the system integration with the AGVs. And I hope that after this session, you will share the standpoint and the same view as I have, that when we talk about safety, we talk about system property. We're not talking about individual cell chemistry or any other component. We have to look at it from an overall perspective of a system. So why we are talking about safety within AGV context? This is what we normally see in our industry. We have machines operating in warehouses, so we're talking about closed spaces, we have human vicinity, and we have also, when it comes to the machines themselves, the very unique operation duty cycle. So non-stop continuous operations, sometimes unintended even. So as we understand, a potential battery failure, a fire, has big consequences, not only on the personal safety and injury of the people working in those factories, but it can also create the damage, the material damage for the company and the equipment. So this can also be very costly for the business itself. I believe that many times when we talk about battery fires, we tend to blame the cells. But if you look on the investigations that are available, there are many other failure components within the battery system, but also outside of the battery system. Here on the energy storage system and also electrical vehicle components, we can see that it can be anything from the control system, so inadequate control strategy or maybe inability to detect a failure and a hazard event. We can talk about wrong electrical failures outside of the system, even sometimes the external fires. So it's really, this only emphasizes and highlights the importance of a good system design and good control strategy. We have 2 battery chemistries that dominate our market. It's the LFP and NMC, as you're aware of. What we don't really talk so much about is how they actually work and what we mean with LFP and NMC. Many times when I'm talking to the OEMs or customers, I hear claims that LFP is supposed to be much more safer, you can operate it with higher temperature, or they don't catch fire. This is simply not true. Both chemistries can burn if they are abused, and furthermore, the starting point is exactly the same for the both chemistries. And I will tell you why. A little bit of a chemistry session here. Here you can see a cell design, a battery cell. We have anode and we have a cathode. So the negative and a positive electrode, lithium-ion ions are transported through electrolyte, and then we have a separator in the middle, which prevents from internal short circuit. When we talk LFP and NMC, we are talking about the cathode material, so the positive electrode. But the starting point of a thermal event is actually a failure in the composition of so-called SE layer. So that layer is located on the anode surface, and that is connected to the graphite. So it's the anode property, and it's not LFP or NMC property. So this needs to be clear. Thermal runaway is a cell failure that it's caused by cell overheating, and it can have both internal but also external factors that it's affecting it. When we talk about internal failures of the cell, we often talk about defects that are connected to the cell manufacturing processes. Those are addressed by quality processes, inspections, end-of-line testing. When we talk about external factors, we can talk about thermal abuse. So let's say the battery is operating in too high ambient temperatures, mechanical stresses, so the battery might be exposed to a vibration profile that was not designed for, or you get the impact, maybe dropping the battery during installation. And we can also look on the electrical stresses. So this is how the battery is being used. You charge it with too high current, or you don't stop charging, and we can end up in an overvoltage situation. We can also have maybe an AGV standing in idle and just pulling the power out of the battery, so we can have deep discharge of the battery. And also cell imbalance, which is very important. This is the nature of the battery. We operate the battery, we're going to have a little bit different behavior in all of the cells. So the cell imbalance is a natural process that's going to happen in the battery pack. But it's important that we detect it and that we can act upon it. And those external factors, they are addressed by good system design and by the control strategies. So this is our role as a battery manufacturer. If we should go through the different components that we have in our systems, we can start from a cell on the top level. So the holder of the electrical energy. There's some safety measures implemented already on that phase, on that stage. Vents and current interruption devices. And we also perform a lot of testing on the cells themselves to qualify and verify the performance and the quality. We take the cells and we assemble them into modules. It's on the module level that we put a lot of redundancy, a lot of measurements, both for the voltage and the temperatures. We also add the cell balancing circuits. Then we have the battery management system, which is the brain of the complete system. It works under principles detect, monitor, detect, and react. So we'll take in all the inputs from our modules, and then we'll verify that the battery is safe, and it is exactly within the operation zone that we want it to be. When we start adding those different components, modules on top of the modules, we start to create a complete system. We have to add additional components to secure the safety of the complete pack. And here we talk about fuses, contactors, current sensors. And then everything is really nice and enclosed within the outer shell, so the battery enclosure. This is normally what you get from us, from the battery supplier. But this is not where our safety work ends. We actually really have to understand and take into the consideration how those batteries are going to be integrated and where are they going to be used. Because that not only improves then the overall design and efficiency of our system, but with that information we can also predict possible misuse of our batteries and then build systems around it to protect us from happening from that. So I would say that our safety work, it starts from the context of where we place those batteries and the risk that we can see that can potentially occur during that operation of that machine. The battery management system is the center, is the brain of the complete system, the most important system when it comes to active safety. It takes in the input from the modules, so it monitors the cells in real time, the whole battery in real time. It will act if there's any anomalies happening. And what it does as well is then estimate the state of the pack. The battery, what's important to understand is that the battery will age. During the aging process, the properties will change. This is nothing that is easy predictable. How the battery will age, how it will degrade, is dictated by the application that uses the battery. The battery management system has to take that into consideration. It has to work throughout the complete lifetime of a battery pack. Not only when you get the new batteries, but in 10 years, when you have all the batteries where the properties are changing, that needs to be also assessed with the battery management system. And you have to ensure of the safety of the system throughout the complete lifetime. So BMS works proactively. It prevents from going into conditions when the battery could be dangerous. We have a defined operational zone where we always want the battery to be. And then if we see that we start to approaching the limits of the operation zone, what we normally do is we escalate and we initiate our failure mode. So that what we do is that we start to sending out warning levels to the applications, and then depending on the abuse severity, we will act as well on our own. But first of all, we always want to, with help of the application, bring the system to stable status. And that is why is that? Is because we always want to optimize the battery. We don't want to disconnect. That is, we always aim to have a big availability of the battery. But if we see that that strategy doesn't work and the battery is being abused even more, the battery will act on its own. And the last resort that the battery can do is to disconnect from the load. The reaction time depends on the abuse, of course. But we have the most important safety function implemented in the BMS, which is then the overvoltage, undervoltage, overtemperature, undertemperature, and current protection. With our Micropower batteries, we actually can achieve performance level D for all of those 5 functions. So we are exceeding the requirements from the legal standard. As you may understand, this strategy control and monitoring puts a lot of demand on the accuracy of our battery management system. This is something that I believe we're not really talking enough about, but if you don't have accurate BMS, you will not be able to control your battery. You'll be basically blind. So this is really important to have in mind. And different chemistries, doesn't matter if you use LFP or NMC, the BMS will have a bit different strategies depending on the chemistry that you're using. What we don't talk about is then how the strategy differs. I'm pretty sure that, for example, those of you who use LFP in your battery system, you being requested to charge the batteries to full from time to time, and that is to address the imbalance problem. Some chemistries are more grateful to work than with others. So if we look on the LFP on the right corner, why you need to charge the battery fully is because during the operational window, the voltage curve is pretty flat. So you can't really assess the imbalance of your batteries. You have to have the battery fully charged to see the gradient and to be able to compare the cells between them. NMC is a bit different. We get a little bit more help from the NMC chemistry. So the gradient that we have of the curve gives us a lot of input and increases the visibility of the battery. But independently of what you have in your pack, it's important to be aware that there's different strategies exist, and you need to ask questions. How good is your stock estimation? How are you performing the cell balancing? What does your battery can manage to do on its own, or what do we have to do? The complementary layer to the active safety is then the passive safety. It works without power or any actuators, so it's built in on the multiple levels. And it's important, but it's actually with the passive safety that we want to control the failure consequences and minimize the risks. We have passive safety built both on the cell, module, and the pack level. As I was stating before, on the cell level, we have vents, we have SIDS. We look on the module level. We work a lot with the propagation strategies, so we don't want to propagate a cell failure to another ones. We also have vents, and on the pack level, that's where we operate both the fuses, pressure relief vents, and also work with fire resistance materials. Good battery system use both passive and active safety. But the purpose of the active safety is to do the proactive work that prevent us from going into dangerous conditions. And then with the passive safety, we protect the environment from eventual failure. Testing and validation is extremely important in our business and is a critical point during the development phase. We have to do the testing on each individual component and on complete system. Serious battery manufacturers, which I hope that you see that we are as well, we invest a lot in cell testing facilities, so we have our own. And that is because we don't want to believe or trust our cell suppliers on the data that are being provided. We do the testing our own. We verify the performance, we verify the quality, but we also want to understand how this battery actually, how the cell actually ages. What's going to happen with it if we try to address different conditions, how it's going to perform. And with that input, we can also tailor and improve our battery management system and the control strategies. On the module level, we verify the mechanical design. We perform a lot of validation on also the abuse testers. So you can see on the upper level, we have a drop test that is being performed on our module. We see that we don't propagate into other modules. We do a complete pack assemblies as well, and then verify the system integration with each component within the battery pack working as they are designed for to protect and prevent from failures. We have a lot of standards, of course, that we're using, but it's not just that. We have our own assessment. So the standards is the absolute minimum, but this is not the whole truth. We do a lot of additional testing, design validation that lasts for many weeks and months to give you the best product. When it comes to AGV and battery integration, as you understand, we do a lot of safety measures already implemented on the battery system. We want the customers to know that we have a safe system that's going to protect itself. But when we talk about integration, we have to see it from the perspective we want to maximize the efficiency and the uptime of the machine. We will always protect ourselves from the battery perspective. But with good integration, we can optimize the operation time and be more efficient. And as we know, the battery is an expensive component, so we want to keep that as good operational as possible. What we mean also with integration is that by using the input from battery, you can optimize the performance in terms of avoiding interruptions, disconnections from the batteries. You can use the temperature input to optimize the mission planning and when to charge, but also when not to charge in case the battery is cold. We can look on the charging strategy. The most optimal strategy to charge the battery is if you have a communication between the battery and the charger. That will also always ensure that the battery receives the voltage and the currents it wants at a given point. So you have real-time adaptation, but we will also able to abort and stop charging when the battery is fully charged or doesn't want to receive anything. I also believe that we can expand the whole safety work to the AGV side as well. There is a lot of smart connected system that you're using on your side. So the facility responses, alarm system can be optimized to also take the input from the battery and have the correct behavior and alarm the people around the vehicle. We have only talked about battery safety from the thermal perspective, but there's many other perspectives and aspects. We can talk about chemical safety, mechanical safety, EMC, electrical. So I feel that there is a lot of regulations that you may not be aware of, but we're also implementing it in our everyday work. But we also strive to do at Micropower to have a very, very close collaboration with the industry. We have to understand in what applications those systems are going to be installed, what are the regulations. So the product conformity, even though it's the OEM responsibility, we always work close with our OEMs to verify and ensure that our products are a match. So a bit of a key point from today. I hope that you understand that battery safety cannot be guaranteed by choosing battery chemistry. The choice of the battery chemistry is dictated by the application in use. How you create a safe system is by having correct control strategies, active and passive systems, layers, cooperating, working together. We have a BMS that will then prevent from failure conditions. It will ensure that the battery is operating within its limits. We have mechanical design that will control the failure consequences. And we have those both systems working together, complementing each other. And the proper system integration is a key point if you want to maximize the battery lifetime and operation. Yes.
Okay,
thank
wonderful.
You.
Thank you, Anna. Big applause, Anna. Anna, I have to tell you something. When Micropower contacted me and said, Alfredo, we want to talk about in the safety conference about batteries, Linus. I say, batteries, okay, let's see what do they have to say. It's a battery, come on. Honestly, when I saw the presentation, I spoke with Anna and their colleagues. I saw a huge amount of information about safety, okay, which we cannot find, for example, in the 3691 because it's another. But in any case, I must admit I was completely ignorant about all these things. So I learned a lot also today. Thank you, Anna, because very, very interesting and very, very linked to the topic of today. So thank you. I have questions. Who has questions? Okay, Omar.
Thank you for the clear presentation. Can we speak of a performance level of BMS functions such as thermal monitoring, overcurrent, overvoltage? Can we rate that to performance level C, for example, as per IEC 13849?
We can achieve performance level D for those functions. So we are starting with our safety concept. So, and that it's our safety goals actually exceed the standards, but we're always using the standards to verify that we have, the correct level. And then, of course, when we talk to our customers, we can verify, we can see the match between the requirements and our design.
And is it common to speak of performance level for those functions in the BMS, or is it new, or is it supposed to be part of the battery standards?
So it's actually when we talk about performance levels, the battery standards, they don't dictate which performance level you should have, because honestly, you don't want to put that requirement on the battery standards and build maybe too expensive system for applications that don't want to have the performance level D or C. So the performance levels from with our AGV systems, they come from 1175. So we have we use machine directive to understand that this is where we want to implement our batteries. We're always talking to our customer. We're asking them about declaration of conformity to understand what standards they're using comply with the machine directive. And in many cases, it is the 1175 that is being used. And from that 1175, that one dictates specifically the performance levels for the batteries.
Thank you.
Good. We have you. Okay. Please introduce yourself.
Yes, thank you. I'm Sander Holleman from Weibo. We've been talking to each other before about your new battery also. But I'm interested in the communication between the charger and the battery. Sometimes the charger is not inside the AGV. How important is it to have contact between the battery and charger in the MMC technology? And how could it be done, for example, when the charger is outside of the vehicle?
I would say that independently, if you have NMC or LFP, you want to have a kind of communication, because then you can, as I said, the charger will be able to adapt in real time to what the battery wants, and you also be able to act fast enough if you want to abort the charging conditions. The battery on its own will protect itself in case of event, but I mean, this is a topic that we have been discussing many times with our customers, because I know of the different solutions that exist on the market, but honestly, from the battery manufacturer standpoint, our statement is always to have the communication between the chargers and the battery, because it's not only the safety aspect is the most important one, but it's also the purely performance efficiency aspect as well of it.
Okay, thank you. And have you some examples of how communication is being done with AGVs or anything between the charging station? Is it done by Wi-Fi or?
Yeah, we can have kind of a Wi-Fi, we can have the cable, I mean the hard, the wired can as well. But what we basically do is that we develop the chargers as well. So we have a very integrated systems. If you buy a charger from the battery and the charger and the battery from Micropower, they're gonna understand each other. There's no integration work needed. What we do is that we send the current and the voltage limits to the charger, and it adapts accordingly to the battery. And it's also providing back the data to the battery, so we have a two-way verification.
Perfect, thank you.
Okay, thank you. Okay. Michael, the award is for you. Third question.
You were talking about active and passive. What was the word?
Safety and systems. Yeah.
What are the active safeties? So you can disconnect the load. Is there anything else?
I mean, the whole battery management system is the definition of the active safety and the active system. So it's all the systems that are monitoring the battery, they are estimating in real time what's happening. It will also send out the power limits to the application, so the application can adjust to the limitations sent by the battery. So we can control, through the applications, we're controlling the battery behavior. And then also, if we see that the application is using more than what the battery wants to give, the BMS is going to adapt automatically and try to derate the performance of the battery. So we have this communication enabled to be able to control and always stay within the operational zone of the battery. But the contactors, of course, are also active safety, because they need the BMS to disconnect. So in case we see that the abuse is getting too big and the application does not actually listen to the battery, we will open the contactors.
All right, thank you.
Okay, good. I have to move.
With some of our customers, we also see that more and more insurance companies start to involve in battery charging and lithium batteries in AGVs. Do you hear a lot about it from your customers, that you have some systems in place to give good information to the insurance companies so they make the right decisions and not just something that they read last week in the paper that an electric vehicle was put in fire or something like that?
Yeah, yes, we are actually having collaborations and discussions and meetings with our insurance companies. We are inviting them as well to our facilities because, like you say, we believe that the discussion is a bit simplified and just focusing on the chemistry. But a lot of, I think, what we can improve and be better at is to explain how we work to create those safe systems. If you look on the standards, they don't dictate safety based on the chemistry. It's on a system level. So in many of our discussions that we had with insurance companies, they were very good and very productive. And I believe that it's we have to stretch out the hand to the insurance companies and initiate those discussions. And I see a benefit, and I think we actually see a good common ground. And I think it's a lot about knowledge. And I believe that in some industries we have come a bit more further than in others. So this is a journey that we have to do together, because in the end we want to have not only the safe systems, but we want to have the best systems. And we don't use the best system on the safety based on the chemistry.
Good. Some more questions? Raise your hands. Come on. Okay. Good. Thank you, everybody. So now, big applause, Anna, please. Incredible presentation. Thank you, Anna. Okay, now we have another coffee break, just half an hour, okay, and then we go just 2 more presentations, other topics, so very interesting. So just please, we see you in half an hour, please. Okay, thank you.